Good afternoon. Welcome to the second ELCO Technical Seminar. Today we are going to introduce you a very important issue for the right choice of an SSR, the heatsink. Often this device is undervalued or not considered at all, but he has a huge importance for the SSR good running. I'll introduce you Mr. Daniele Cavaliere, who's our technical department manager. Mr. Cavaliere will explain to you in detail how to choose the right heatsink.
Good afternoon, everybody. My name is Daniele Cavaliere. I am the technical manager of ELCO. We are here today to speak about power dissipation and heatsink sizing. Heatsink is an aluminum device, as you probably already know, specifically designed to optimize the temperature dissipation of the SSR. To do that, a typical heatsink profile has a lot of wings. This is to reach the maximum exchange area possible with the minimum quantity of material and in less space possible. A larger exchange area means a better temperature exchange, so a better dissipation. The exchange area, with the kind of material used, defines the thermal resistance of the heatsink. That is the value that we wanted to consider, expressed in degrees per watt. An example: if we get a 2 Kelvin watt heatsink and we must dissipate, for example, 10 watts, we will get a delta T between the environment and the SSR metal plate of 20 degrees. So, with an ambient temperature of 40 degrees, we will have 60 degrees on the metal plate of the SSR. Now we are going to speak about the power we need to dissipate. SSR, as per his own construction, has a voltage drop on the output stage. That means a proportionate power drop on the power components related to the load current applied. On the data sheet, you can find the maximum value of the dropout voltage of the ELCO SSRs. To evaluate power dissipation, we can use the typical one, that is 1.2 voltages. Considered this value, we get 1.2 watts of power loss per each ampere applied on the SSR output. And we need to dissipate this power to ensure the SSR doesn't exceed the maximum allowed working temperature on the electronic components inside. To do that, we need a proper sized heatsink. On the main components, one of the main components we must consider is the power one. That usually has a maximum allowed temperature of 125 degrees Celsius. As producer, we know all the parameters to calculate for each model of SSR the thermal resistance from the components to the heatsink. And we can, if we want, to push some particular SSR to work with a higher temperature on its metal plate compared to others we have. As today we want to focus on a generic calculation that can be useful for each model of ELCO SSR, we can leave out this aspect and take as reference a maximum temperature allowed on the metal plate of the SSR. I suggest to use maximum 100 degrees. Let's move on a practical example. We can suppose to have a load of 25 amperes. Now we are focused on the power dissipation, so on the heatsink sizing. With a dropout voltage of 1.2 and a current applied of 25 amperes, we get 30 watts of power drop. As on an industrial application, we can consider to have more or less 40 degrees, and we know we can't reach we can't exceed the 100 degrees on the metal plate of the SSR, we have a maximum allowed delta T of 60 degrees. Now we have all the needed values to identify the maximum thermal resistance of the heat sink we need to ensure this result. 60 degrees divided by the 30 watt we have, we get 2 degrees per watt as a thermal characteristic of the heat sink. So, looking at our production range, we are speaking about the ELCO HS03. With this heat sink, we can ensure to have maximum 100 degrees on the metal plate of the SSR with the 25 amps of load on an environment of 40 degrees of ambient temperature. Well, there are a couple of points we must consider when we are going to assemble the SSR with our heat sink on our application. All the previous considerations we have made are on a perfect connection between the heat sink and the SSR. At this point, it's clear how to select the heat sink we need. And we have seen that the power dissipation defines the first limit about the maximum load current we can apply. The other feature that limit the maximum current we can apply is the maximum current carried by the SSR. This is due to the characteristics of the power components used. It is possible to use a bigger SSR related to the current we are able to dissipate. But only if there are factors involved like, for example, a particular rush current that the smaller SSR can't sustain. Otherwise, there are no need to put, for example, a 50 amps SSR on a heat sink that can dissipate power only for 25 amperes. Both limits we have just spoken about must be considered when we are going to choose the switching solution to drive our load. The example we have just explained is about an SSR that is constantly active with a continuous current flow. On a real application, we expect the customer choose to use the SSR because he needs to perform a lot of switches in a short time. A typical use of the SSR is on a thermoregulation process where there are a cycle time, maybe a few seconds, and the relay switch on and off with a variable duty cycle. An example of duty cycle is if we have a duty cycle of the 30% and a cycle time of 10 seconds, we will get 3 seconds on and 7 off. In that case, we still need an SSR able to carry the nominal current of the load we have. But we can consider in that case, we still need an SSR able to carry the full load current we have on the load, for example 25 amps. But we can evaluate a smaller heat sink, saving money and space. As the heat sink needs time to heat up and cool down, in the most of cases we can consider to dissipate the average power. So, if during the switch on of the process the heat sink is cool and the first heating slope, that usually is the longest one, keeps it at a temperature lower than 100 degrees, we can dimension a heat sink for a current that is the average one we detect during the modulation of the process. For this kind of sizing, I suggest to perform a specific temperature test to ensure to never exceed the 100 degrees on the metal plate of the SSR. A practical example on this topic we have found is on application that heats up a small boiler. The load is a 3-phase 15 amperes that has a full power only at the startup only of 5 minutes. And then the maintenance where in the worst condition the duty cycle is the 50%. The customer is using a 3-phase SSR that in full load condition will require a heat sink like our HS02. In this specific case, he has only assembled the relay on the metal plate of the cabinet. The temperature test performed on this application show that the SSR can work without any kind of problem, absolutely without a dissipation solution. Here the cost and the space saving was as per the installation of an HS02. A different ELCO solution is the use of integrated heat sink SSR. These devices are designed for a 100% duty cycle application, so for a full load, with an ambient temperature of 40 degrees, where the power part is suitable to carry the nominal current and the heat sink is dimensioned for a full load application. When the customer uses this kind of SSR, there are no sizing or consideration needed. This is a plug-and-play solution we can provide. If we consider one more time the SSR is usually installed on an application with a DT that is lower than 100%, we can confirm that this solution has a considerable margin kept if we look at power dissipation. The products we want to suggest on this way are the single-phase series SSR 170H in sizes 15, 20, 25, 30, 40 and 60 amps with two different line voltage, 240 voltage and up to 600 voltage. Then we have the dual-phase series SSR 270H in sizes 15, 30, 35 and 60 amps. And then the 3-phase series SSR 370H in sizes 10, 20, 25 and 40 amperes. This line here up to 600 voltage.
As introduced by the ELCO Technical Seminar presentation letter, we are glad to share with you a promotion. To all the event subscribers, we will guarantee an extra 3% discount on all the Series 70 products. All promotion details will be introduced to you by an email during the next few days.